Today we are going to talk about angles in polygons. This will be a brief introduction with no exercise set. We first talk about two-dimensional shapes. A two-dimensional shape is a closed geometric figure like a triangle, a rectangle, or a polygon like this hexagon. It is closed as in there is no gap, and it has sides, generally speaking, except from the fact that circle doesn't have any sides. Now there are those two-dimensional shapes with regular and irregular ones. Well, we will come back to that in a few videos later, but when we talk about regular, we talk about the side lengths being equal and angles being equal. And if we're talking about a triangle, then it is an equilateral one. In equilateral triangle, we have all sides and all angles equal. And all the other triangles like scalene triangle, isosceles triangle, right angle triangle, these are irregular triangles. When it comes to quadrilaterals, which means a two-dimensional shape with four sides, the regular one is a square, as you may guess. And all the others like rectangle, parallelogram, right, these are irregular. Now, we do not have special names when it comes to two-dimensional shapes with more sides, like we have those pentagons with 5 sides, hexagons with 6 sides, and it goes on like that, heptagons and octagons and so forth. What happens is that we just say this is a regular pentagon or this is a irregular heptagon and such. Now, when it comes to the name, the names are also really uninteresting, because there is this gon, which means side in Latin or ancient Greek probably, and penta is for 5, hexa is for 6, hepta is for 7, and octa is for 8. So it's 5-sided, 6-sided, 7-sided, and so on. So when it comes to polygons, that's the general name for those 2D shapes which has more than 4 sides. Poly stands for many, so it's a many-sided shape. That's what we're talking about. Right. Well, there are 2 facts, 2 statements that I'd like to show you to remind you, which we would be using in the rest of the Angles in Polygons chapter. Now the first one is, well, when you have a straight line, you have a straight angle, which is 180 degrees. And when it comes to a polygon, like this one, let's say this is a pentagon, and if you extend one of the sides, you will have a straight angle as shown in here. So this will be the polygon. It could be any polygon. Here in this case it's a pentagon, let's say, and this part, so this is the polygon bit, so this angle here is the interior angle, so you write like that, interior angle here, and this one is the exterior angle, basically because it is outside the polygon. So interior angle is inside the polygon, exterior angle is outside the polygon. Now, in each polygon, the sum of one interior angle and one exterior angle add up to 180 degrees because this is a straight angle. That's the first statement that you must keep in mind. The second statement is about angles in triangles, which you already know. The sum of interior angles of a triangle is 180 degrees. Now, I'd like to prove this to you. So these are two angles. Let's say this is A and B here, and this is the angle at the top, which is C. Now, if you have a parallel line drawn at the top of the triangle, so this is parallel to the base, okay, then from the property of alternate angles, you will have this angle to be A, you'll have this angle to be B, right? So these will be the same, this will be the same as this one. So what happens is that these three angles, A plus B plus C, will give you 180 degrees. This is how you can prove that the sum of interior angles of a triangle is 180 degrees. And last but not least, when it comes to the notation of polygons in general, right, notation, there is this letter N that we use. This refers to the number of sides. Now, actually, the thing is that when you have, let's say, a hexagon, okay, you have 1, 2, 3, 4, 5, 6 sides, so N is 6. But at the same time, you have 1, 2, 3, 4, 5, 6 angles. So when we're talking about number of sides for N, we also refer to the number of angles. So that's all for this video. This was just an introduction. There is no exercise set to solve. You can now proceed to the next video, which will have exercise set. Thank you.